Hello everyone. In today's lecture, we will learn about the sum and difference formulas in trigonometry. Now in algebra, we had also learned about the sum and difference formulas for two variables. For example, the a squared minus b squared formula, if you recall, was a plus b times a minus b. We had learned about the a cubed plus b cubed or the a cubed minus b cubed formulas. Then there was the a plus b whole squared or the a minus b whole squared formulas as well. In trigonometry, we have the sum and difference formulas, which use the trigonometric functions of the sine, the cosine, and the tangent functions. Essentially, they calculate the trigonometric ratios for the difference of two angles, be it measured in degrees or in radians. It's essential to know what those formulas are and how to apply the formulas or those identities. At the pre-calculus level, these formulas will help us easily calculate the trigonometric ratios of angle values which are not necessarily special angles. We will learn the process of doing that. Similarly, they are also used to verify complex trigonometric identities. At a higher level in calculus, these formulas are often used to simplify complex wave functions. In the real-world application in the field of engineering and physics, they are also used in acoustics and wave theory. Your noise-cancelling headsets use technology which is of course built on mathematics, and many of the mathematical calculations behind these technology would be using formulas like the sum and difference formulas in trigonometry. So we will go on to learning more about them. First, we will go through the entire list of the sum and difference formulas and then go through examples on how to apply them and solve problems. Here's how we will proceed through this lecture. We will start with the formula for the cosine function of the difference of two angles, and then we'll include the sum and difference formulas for both cosines and the sine function, and then finally we will look into the sum and difference formulas for the tangent function. We will begin with the formula for the cosine of the difference of two angles. The way we write it out is cos of, within brackets, alpha minus beta. Now right at the outset, let me make it clear that you cannot use the distributive property to expand cos of alpha minus beta. Cos of alpha minus beta is not equal to cos of alpha minus cos of beta. So let's cross that out. Please do not make that mistake. Instead, cos of alpha minus beta has the expanded form, which is cos of alpha multiplied by cos of beta plus sine of alpha multiplied by sine of beta. Let's look at this a little more closely, which will help us to remember this formula. First of all, if it is a cos function and it's a difference, that means if we have a minus between the two angle measures, then in the expanded form, it's a plus. And then in the first term of this expanded form, we have both alpha and beta with the cosine function. So cos of alpha times cos of beta. It's the same trigonometric function cosine in the first term. In the second term, it's the sine function, so sine of alpha times sine of beta. So again, for the cosine function of the difference of two angles, it's a plus, it's a sum between the two terms, and the first term is homogeneous. That means both alpha and beta will use the cosine function, and in the second term it's the sine function, so sine of alpha multiplied by sine of beta. So the cosine of the difference of two angles equals the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. Let's work through an example of applying the difference formula for cosines to find an exact value. It says here we know that cos of 30 degrees is equal to square root over 3 by 2 based on the special angles table. Obtain this exact value using cos of 30 degrees equals cos of 90 degrees minus 60 degrees and the difference formula for cosines. In other words, they are telling us that we already know from the special angles table that cos of 30 has a ratio of square root over 3 by 2. However, we have to find the exact same value now using the difference identity for cosines. So the way they have written this out is as a difference of two angles. They've rewritten 30 degrees using special angles and using the difference of two other special angles. Cos of 90 degrees minus 60 degrees, where 90 degrees represents alpha and 60 degree represents beta. Let's write out the formula for the difference of cosines. That's cos of alpha times cos of beta plus sine of alpha times sine of beta. Therefore, the first step is to break up the angle, the single angle, and write it in the form of the difference of two angles, preferably using special angles whenever possible, and then just plug in the values of alpha and beta into the formula and perform the calculation. So here we go. We have cos of 30 degrees equals cos of 90 degrees minus 60 degrees, where again 90 degrees represents alpha, 60 degrees represents beta. And then the next step will be to write it out in expanded form. So cos of 90 degrees times cos of 60 degrees plus sine of 90 degrees times sine of 60 degrees. Again, remind yourselves that if it's the difference of two angles for cosine, then the expanded form has a plus in it. Now, cos of 90 degrees has a value of 0. Cos of 60 degrees has a value of 1/2. And then the plus sign, sine of 90 degrees has a value of 1, and sine of 60 degrees has a value of square root over 3 divided by 2. So when we complete this calculation, 0 times 1/2 is 0, and then 1 times square root over 3 by 2 is square root over 3 by 2. When we sum the two terms up, it's square root over 3 by 2. That shows that cos of 30 degrees using the difference formula for cosine has a value of square root over 3 by 2. So let's erase this and see how the solutions look like, whether they've followed the same process or not. So yes, cos of 90 degrees is 0. They've plugged in 0 for cos of 90 degrees, and cos of 60 degrees is 1/2, and then the plus sign, sine of 90 degrees is 1, sine of 60 degrees is square root over 3 by 2, which after summing the two terms up gives us a value of square root over 3 by 2. In the second example, we are still using the difference formula for cosines. However, we are moving in the reverse direction in the sense that we have been given an expanded form of the difference formula for cosines, and we have to backtrack the steps to get to the exact value. Here in this expression, let's study this closely. Alpha has a value of 70 degrees, beta has a value of 40 degrees, and then in the first term, both angles use the cosine function. So we have cos of 70 degrees times cos of 40 degrees, and then a plus sign followed by the sine function applied to both alpha and beta. So at this point, we should be able to recognize that this is an expanded form of the difference formula of cosines and can be written as cos of alpha minus beta. So let's do that. We can write cos of 70 minus 40, which gives us cos of 30 degrees. 70 minus 40 is 30 degrees, which has a ratio of square root over 3 by 2. Let's pull up the solutions here. So they've done the same thing. Cos of 70 degrees times cos 40 degrees plus sine 70 degrees times sine 40 degrees is equal to cos of 70 minus 40, which gives us cos of 30 degrees, which is equal to square root over 3 by 2. All right? In example 3, we will be applying the difference formula for cosines to verify identities. The identity given to us is cos of alpha minus beta divided by cos of alpha times cos of beta equals 1 plus tan of alpha times tan of beta. Now, we had discussed previously the strategy of verifying identities where we start with the more complex expression within the identity and try to simplify and reduce it to the other expression, to the more simpler expression. And that's what we are going to do here. We'll work with the left-hand side of the identity, which seems to be more complex than the right-hand side. We see the numerator of the left-hand side expression is a difference formula of cosines, correct? Cos of alpha minus beta, which can be expanded in the form cos of alpha times cos of beta plus sine of alpha times sine of beta. So that's going to be the first step in the process where we will expand the numerator of the left-hand side of the expression. And that's what's being done here. They have written out the numerator in the form of cos of alpha times cos of beta plus sine of alpha times sine of beta divided by cos of alpha times cos of beta. The next step will be to separate the two terms in this fraction. We are going to separate the first term using the denominator cos of alpha times cos of beta, and the same for sine of alpha times sine of beta, so that they are two separate fractions. So let's pull up the next step. We have cos of alpha times cos of beta divided by cos of alpha times cos of beta as the first term, plus sine of alpha times sine of beta plus cos of alpha times cos of beta. Now let's look at the first term here. The factors in the numerator and the denominator can be divided. So cos of alpha and cos of alpha will divide to give us a 1. Cos of beta and cos of beta will divide to give us a 1 as well, and 1 times 1 is a 1, therefore this entire first term can be reduced to a 1. At this point, I want to alert you that cos of alpha divided by cos of alpha is not 0, it is 1. Just like 5 divided by 5 is a 1, 3 divided by 3 is a 1. Cos of alpha divided by cos of alpha is a 1. It's not 0. Same for cos of beta divided by cos of beta. It's a common mistake I come across from time to time, so I wanted to alert you to that so you don't make that mistake. The other side remains as sine of alpha times sine of beta divided by cos of alpha times cos of beta. And that's what they've done here in this step. This process will continue in the next slide, where we will start with 1 plus sine of alpha times sine of beta divided by cos of alpha times cos of beta. All right? So here we go. We start with cos alpha and cos alpha dividing in the first term with the 1. Cos beta divided by cos of beta is a 1. So we end up with 1 plus sine of alpha divided by cos of alpha multiplied by sine of beta divided by cos of beta. So for the second term, they have written it out as two fractions using the multiplication sign. And then sine of alpha divided by cos of alpha, sine divided by cos, recall the quotient identity, gives us tan, correct? So the first expression is tan of alpha, and the second sine divided by cos will give us tan of beta. Therefore, we'll end up with 1 plus tan of alpha times tan of beta, and that proves that the identity is verified at this point. So far, we have looked at the difference formula for only cosines. Now we will list all the formulas for the sum and difference of angles for both cosines and sines. We will start with the sum formula for cosine, which is cos of alpha times cos of beta minus sine of alpha times sine of beta. Now this looks very similar to the difference formula for cosines, except that for the sum formula, when you have a plus between the two angles within brackets, in the expanded form, it will be a minus. All right. The second formula is the difference of cosines. We have already seen this before and even worked through some examples applying this, so it should be pretty familiar by now. Cos of alpha minus beta is equal to cos of alpha times cos of beta plus sine of alpha times sine of beta. So if it is a difference of cosines, then you add the two terms in the expanded form. The next one is the sum of the sine function, the sum of angles of a sine function. Now let's look at the expanded form of this. It's sine of alpha times cos of beta plus cos of alpha times sine of beta. So let's look at the terms. In the cosines, we had a homogeneous function in each of the terms. Cos in the first term, all sine in the second term. In the sine function, we have a mixture. We have in the first term sine of alpha times cos of beta. So the two trigonometric functions in the first term are different. Sine of alpha times cos of beta. So sine of the first angle multiplied by the cos of the second angle plus cos of the first angle times the sine of the second angle. Also to note is that if it is sum, if there's a plus within brackets between the angles, then in the expanded form, we also have the plus sign, unlike in the case of the cosines. And then for the difference of two angles for the sine function, sine of alpha minus beta, the expanded form is sine of alpha times cos of beta minus cos of alpha times sine of beta. We'll just have to remember these sum and difference formulas using whatever way works for us. All right, so I've given you some tips to help remember the formulas, but then you can come up with different mnemonics if it helps remember the formulas. We'll now work on an example where we'll apply the sum formula for the sine function to find an exact value. The angle measure given to us this time is in radians instead of in degrees. The question says find the exact value of sine of 5 pi over 12 using the fact that 5 pi over 12 equals pi over 6 plus pi over 4. So here they have split the angle measure 5 pi over 12 and written it as the sum of two special angles. Now, more often you will not be given this split of the angle measures as the sum of two special angles. It'll be upon you to figure out how the angle measure can be written as the sum of two special angles. But this time they've made it easy for us. So let's just use the information they've given to us. We have to work with pi over 6 and pi over 4, where pi over 6 will be our alpha and pi over 4 will be our beta. Now we have to use the sine function, the sum of the sine function. Therefore, let's write out what the expanded form of sine of alpha plus beta would be equal to. It's sine of alpha times cos of beta plus cos of alpha times sine of beta. So that's the first step. Write out the expanded form of the particular formula that you should be using, and that's what they've done here. Sine of alpha plus beta equals sine of alpha times cos of beta plus cos of alpha times sine of beta. And the next step, we will plug in pi over 6 for wherever alpha occurs and pi over 4 wherever beta occurs. And that's what they've done here. Sine of 5 pi over 12 equals sine of pi over 6 plus pi over 4, and in the expanded form it's sine of pi over 6, which is alpha, times cos of pi over 4 plus cos of pi over 6 times sine of pi over 4. Now write out the ratios for sine of pi over 6 and cos of pi over 4. Sine of pi over 6 is 1/2, and cos of pi over 4 is square root over 2 divided by 2, plus cos of pi over 6 is square root over 3 divided by 2, and sine of pi over 4 is square root over 2 divided by 2. Now we have to multiply the first two ratios and then the next pair of ratios on the right hand side of the plus sign. Remember the PEMDAS rule, that multiplication division before addition and subtraction. All right, so make sure you follow that. So we have half times square root over 2 divided by 2 would be square root over 2 divided by 4. So let's write that on this left hand side space. So 1/2 times square root over 2 by 2 will give us square root over 2 divided by 4. 2 times 2 in the denominator is a 4, and then square root over 3 divided by 2 times square root over 2 divided by 2 will be square root over 6 divided by 4. So we will have the plus sign followed by square root over 6 divided by 4. Both the fractions have the same common denominator, so we can write it as a single fraction by putting it under the common denominator of 4. So this can be written as square root over 2 plus square root over 6 divided by 4, and that is what they got here as well. We cannot reduce this any further. The next set of problems is a little bit different from what we worked before, in the sense that we have been given a particular trigonometric function for two different angles that lie in two different quadrants, and we've been asked to find the value of the cosine function for a particular angle, in this case alpha. So I'm going to first read through the question and understand the information provided to us so that we can determine how to use it to find the ratio they've asked for. It says here, suppose that sine of alpha equals 4/5 for a quadrant 2 angle alpha and sine of beta equals 1/2 for a quadrant 1 angle beta. Find the exact value of cos of alpha. Again, keep in mind here that these two ratios are not for the same angle. They are for two different angle measures. One is alpha, the other one is beta, and these angles lie in two different quadrants. Now, whenever we work with a ratio, the first thing that we must do is find the other side. A ratio only represents two sides of a right triangle within a unit circle. But when we have sine of alpha equals 4/5, what is the sine ratio? The sine ratio is y divided by r, where based on 4/5, y would be equal to 4, r would be equal to 5. We have to find x, which is the third side. Although we don't need it for the sine function, but because we have to find the cosine function, the first step would be to use this information to find the third side of the right triangle. So that's going to be the first step. I'm going to pull up the solutions here. See, sine of alpha equals 4/5 is a second quadrant angle. So they have drawn the right triangle in the second quadrant, and r, which is the hypotenuse, is 5. We know that from the definition of the sine function, which is y divided by r. And the measure, the vertical distance, the distance along the y-axis is 4, correct? So 4 over 5. We don't know what x is, therefore we have to find what x is. Now we see that x is along the negative x-axis, so it'll be a negative value. let's just pull up the solutions, how they've used the Pythagorean formula to find the third side. So x squared plus y squared equals r squared is the Pythagorean formula. So they plug in 4 for y and 5 for r and get x squared plus 4 squared equals 5 squared. So we have to solve for x, so we need to isolate x squared in the next step. So we have x squared plus 16, 4 squared is 16, 5 squared is 25. Solving for x, we get x squared equals 9. 25 minus 16 gives us a 9. Therefore, x will be equal to negative 3. Now, x would be equal to plus minus 3, but because this is a second quadrant angle, the x value will be a negative 3. Therefore, they have eliminated the plus positive 3 and kept the negative 3 for the value of x. All right? So cos of alpha is equal to x divided by r by definition. We know the value of x now, so we can write this as negative 3 divided by 5. That should be the final answer. X is negative 3, r has a value of 5. So the final answer is negative 3 over 5. And just remind yourself as a cross check that cosine for a second quadrant angle should always be a negative value, and that's exactly what we got here. All right? Now with the same problem, we've been asked to find cos of beta. Earlier, we were asked to find cos of alpha. This time, it's the same information provided to us. We have to find cos of beta, the other angle. Again, let me read through the question anyway. Suppose that sine of alpha equals 4/5 for a quadrant 2 angle alpha and sine of beta equals 1/2 for a quadrant 1 angle beta. Find the exact value of cos of beta. Now, this time we are being asked to find the cosine of beta. Therefore, we will use the information which is sine of beta equals 1/2 for a quadrant 1 angle. However, the process is going to be the same. We have to use the Pythagorean formula to come up with the third side and then put together the ratio for cos of beta using the different values of the sides of the right triangle in the first quadrant. So let's pull up the solution. We have the right triangle drawn in quadrant 1 and sine of beta equals 1/2. So sine of beta is defined as y divided by r. Y has a value of 1. That's the vertical distance. R has a value of 2 based on the ratio. So we need to find x this time, but this time it's going to be a positive x. It's along the positive x-axis. So the x value better be a positive value. Again, we'll pull up the Pythagorean formula. X squared plus y squared equals r squared, where y will be plugged in with a value of 1 and r will be plugged in with a value of 2. And this should be 2 squared. Let me correct that. It's 2 squared, right? So what's the next step? It's x squared plus 1 equals 4. Therefore, x squared will be 4 minus 1 equal to 3. And therefore, x will be positive square root over 3. So because this is a first quadrant angle and x lies along the positive x-axis, therefore, we choose the positive square root over 3 value. So now let's pull up what cos of beta would be equal to. Cos of beta equals x divided by r. Plug in the value square root over 3 for x, and r has a value of 2. Therefore, square root over 3 divided by 2 is the final answer. We will now work through part 3 of the same question, which asks us to find the exact value of cos of alpha plus beta. So as you can see, this time we have to apply the sum formula of the cosine function. The expanded form of this formula is cos of alpha times cos of beta minus sine of alpha times sine of beta. So once we have the expanded form, all we need to do is plug in the ratios for cos of alpha, cos of beta, sine of alpha times sine of beta, and subtract the two to get to the final answer. Now, sine of alpha and sine of beta values were already given to us in the question itself. We found from our previous work the values of cos of alpha in part A and cos of beta in part B. So we can just use the same values to complete this question. So from our previous work, sine of alpha is 4/5 given to us. Sine of beta is 1/2. We calculated cos of alpha is -3/5 and cos of beta is square root over 3 divided by 2. So plug in these ratios correctly into the given form. Cos of alpha times cos of beta minus sine of alpha times sine of beta. Cos of alpha is -3/5. Cos of beta is square root over 3 divided by 2, and then there's a minus sign. So for the cosine function, to remind you, if it's the sum of two angles, then the expanded form has a minus sign in between the terms. All right. And sine of alpha is 4/5. Sine of beta is 1/2. Again, you multiply first each of these ratios within the terms. So -3/5 times square root over 3 divided by 2 is -3 times square root over 3 divided by 5 times 2 is 10. Correct? That's the denominator. And then minus sign, minus 4 times 1 in the second term. 4 times 1 is 4 in the numerator. 5 times 2 is 10. And then we just combine the two fractions under a common denominator to get -3 times square root over 3 minus 4 divided by 10. That's the final answer. And finally, in part D, it says find the exact value of sine of alpha plus beta. So this is the sum formula for the sine function. Again, the process is the same as what we did in the previous step for the cosine function. Let's write the expanded form for the sine function of the sum of two angles. It's sine of alpha times cos of beta plus cos of alpha times sine of beta. Again, we do know the values of sine of alpha and sine of beta. We calculated previously the values of cos of alpha and cos of beta. So let's bring that up from our previous work. Here are the different values and we just plug them in correctly. So sine of alpha will be 4/5. Cos of beta will be square root over 3 divided by 2 plus, there's a plus sign, so cos of alpha is -3/5, sine of beta is 1/2, and then multiply the ratios within each term and then just add them up. We'll end up with an answer of 4 times square root over 3 minus 3 divided by 10. We are now ready to learn the sum and difference formulas for tangents. The tangent of the sum of two angles is given by the formula tan of alpha plus tan of beta divided by 1 minus tan of alpha times tan of beta. The tangent function of the difference of two angles alpha and beta given by tan of alpha minus beta has the formula tan of alpha minus tan of beta divided by 1 plus tan of alpha times tan of beta. Now I'm going to quickly compare the two formulas and see if there's a way which can help us remember the formulas. Essentially, the formulas look pretty much alike, except there's a difference in the signs in the numerator and denominator. when we are looking for the tangent of the sum of the two angles, then the numerator expression has a plus sign. Therefore, tan of alpha plus tan of beta in the numerator, and in the denominator, we have a negative sign. So it's 1 minus tan of alpha times tan of beta. When we are talking about the tangent of the difference of two angles, that's tan of alpha minus beta, then the expression is the same, except that instead of a plus, we have a minus in the numerator, and in the denominator, we have a plus. All right, so that may be an aid which might help you to remember the formulas. All right. We will now work through one final example where we apply the sum formula for the tangent function to verify an identity. The identity given to us is tan of x plus pi equals tan of x. Now we always work with the more complex expression in the identity and try to simplify it to get to the other expression in the identity, right? And that's what we are going to do. The complex expression here is tan of x plus pi. Also, we know that this is the tangent of the sum of two angles. One of the angles is x, the other one is pi. So we can use the formula for the tangent function of the sum of two angles. And let me write that down. It's going to be tan of alpha plus beta was equal to tan of alpha plus tan of beta divided by 1 minus tan alpha times tan beta. That's the formula. And in this case, alpha is x and beta is pi. So we're going to go ahead and plug in the correct angle measures in the expanded form given by this formula. Correct? So we start with tan of x plus pi equals tan of x. In the next step, we just work with the left-hand side expression, which is tan of x plus pi equals tan of x plus tan pi divided by 1 minus tan of x times tan of pi. So here we have plugged in the variables and the values given in our particular identity to replace alpha and beta. And then in the next step, we have to know tan of pi equals 0. So tan has a ratio value of 0 in both the numerator and denominator. So that's going to get replaced by 0. And that's what they do here. Tan of x, when we replace tan of pi by 0, it becomes tan of x plus 0. In the denominator, it becomes 1 minus tan of x times 0. And tan of x times 0 is equal to 0. Anything multiplied by 0 is a 0. So we end up with tan of x in the numerator. Tan of x plus 0 is tan of x divided by 1, which is tan of x, and that is what the right-hand side expression in the identity is. So we have verified our identity.